Hello everyone, this is an update on the Evo setup of Tesla coils, and I would like to see, I'll show you, my setup update. I changed the coils to be all the same grade and gauges, and I wanted to show you the progress. Actually, this is a tune-up more than anything else. This is how I tune it, waiting for the video of Evo. And let's see if this is the right way or not. But I'm going to show you the scope as well. You will see the scope shot and also the power supply, and there is a heater I'm putting as a load on and off during the video. So for now it's on, but first of all I'm gonna show you the coil 1, L1 and L2 without any any other coils, and we'll see on the scope how it looks like as we do it. I'm gonna put my ground strap, of course, because we're dealing with over 1 kilovolt, and yes, I'm gonna put it on the same frequency as I put it last time, and you will see the variation of the coil distance, not only on L2 and L3, but more likely in between the load and the L3, which I wanted to show in the video. So I hope I can do that with the multi-camera setup I have now, and we'll see. Okay, and the power supply is on. I'm putting the scope. And channel 1, channel 1 on the pulse, and channel 2 on the L4, which is not loaded right now, and L3 is not loaded. So gonna show now the scope, and this is the pulse. I'm going to take off the measurement for now, and that's how it looks like. It's pretty clean actually, and if I can see, $500. Let me change that to channel 1, and it's 1.1 kilovolt, 1.68 kilovolt. Okay, and now I'm gonna check just the distance between coil 1 and coil 2. And as you see on the scope, I'm showing the voltage on L1, the impulse, and I'm gonna show also the L2, and as you see, it does not vary that much. Okay, if I change the frequency, it's just cleaning the signal itself. If I go lower, you see, so I'm gonna keep it as is and see the difference between the difference in distance between L2 and L3, which is the important one. So let me turn the other side. My ground is on, and if I put this just like that now, remember this is the L4 is measuring, so I'm going to put the 25 millimeter in between, and then the L4. You see, the L4 is flush to L3 right now, and if I vary the distance between, the L3 get more amplitude. You see? So what I'm gonna do, I'm gonna put the two rings that I prepared, which do not block anything. And I'm gonna adjust the scope to get the best adjustment. By the way, in the view of the power supply, you will see also the measurement on the load, the temperature. So you see, the high frequency is affecting the measurement of the temperature. And I'm gonna show you that later on, but for now I'm just gonna adjust the I put it away from the high frequency because I can tell right away it's it's not doing the job. So I'm gonna adjust the impulse. See the trigger point. So the pink one is the voltage on L2, on L4, and the green is the current on the load. So if I change the frequency, you see, and you see the consumption also rise up, but also the power on the load. Let me readjust the scope. These are the pulses. And okay, now I'm gonna show you the distance and how it varies even in the consumption too. See? And if I get rid of the two rings, see, the distance really matters with the frequency because it reached the end of the pulse. If I switch that voltage to L3, now I'll show you a different angle. You see, that's the L3. It varies with the distance between L1 and L2, L2 and L3. And this is the L4. Let me show you the L4. Now I'm gonna take off the L1, which we know that the pulse was not gonna change. It's still the same with the distance. But what we're gonna change is the L3 and L4. So let me readjust the power of the scope. Now I'm gonna just show you the L3 and L4. L4 is under load, don't forget. So let's see first. This is L4 I'm moving, eh? You see? The distance really matters. For this, so what I'm adjusting at, I'm adjusting the L3 to the maximum and see if L4 follow or not. So I'm gonna put the second ring. Now that's the maximum of L3. Now L4, that's the maximum of L4 too, right there. Okay, so the distance is as is now. Let me see if the frequency will change this relationship between L3 and L4. That's pretty much is the same. Let me show you the frequency. The frequency is 133. That's pretty much is the maximum. And the consumption is a bit less. If I take the load off, let me take out the load. Don't forget, the load is only 12 ohm resistor, that's all. It used to be like a heater to melt the fridge when it comes to over temperature. See? Now I'm gonna check without load how much I have. and the L2 no, remember we using now L3 and L4. So L3 is 500 volt peak to peak at 130 kilohertz, and the one I'm loading is 322 24 volt, and RMS is 92 volts. This is without load. And notice the consumption. Consumption is 62 volts, 25 250 milliamp. And I'm gonna put the load on. So the load is connected between the L4 and the ground. Between L4 and the ground. And there is nothing in between. I disconnected this, L3 and L4. It's the same result. If I leave this on or off, it's the same result. So basically the L4 is not connected at all with L3. It's just sitting on it, taking that power from the flux and converting that to power to the load. Like this one here, you see L3 and L4 with the load, except there is no capacitor in here for now. So that's my update for now. I'm working on it. I did not give up yet, but what I'm trying to do is getting the maximum power that we can do, provided that I have only 60 volt DC and that limited setup. I mean, the coils can be bigger and all this stuff. Everything can be expanded and making it bigger, but it have to be proven first if it's worthwhile or not. So yeah, is it really free energy? That's the thing. It's not. I don't think there is a free energy here. Transfer of power, yes, there is a transfer of power. There's no problem, and I see it on in phase 2. I have no problem with that. It's obvious. Free energy. That's the thing. It's not. I don't think there is a free energy here. Transfer of power, yes, there is a transfer of power. There's no problem, and I see it on in phase 2. I have no problem with that. It's obvious, and I love that card of Evo. Makes a big difference in burning MOSFET. I burned so many. Now it's running stable, and I really appreciate that. So for now, that's it, guys. I'll keep you posted. All right. Thank you for watching.